Static NAT is used wherever there is one-to-one translation needed. Dynamic NAT overloading, the third one which we are going to see now, is used wherever we want many computers from inside to use one or two addresses. You see, this NAT is good, but it cannot use too many public IP addresses. The static NAT uses too many public IP address. If you want to give one-to-one to everyone, it needs a lot of public IP address, which is not possible. Dynamic NAT is slower because at a time, two devices cannot use the same IP address. So if I have two addresses in pool, only two devices can go online. All the rest should wait for the address to get released by the computer which is using. The delay will be very big, and the consistency will not be same. The delay consistency, it will be varying every now and then. We call it as jitter. Jitter is one word, latency delay is another word. Latency means delay, but jitter means not simply delay, inconsistent delay. Sometimes there will be 5 millisecond delay. Sometimes it will be 50 millisecond delay. Sometimes it will be 300 millisecond delay. So the delay is also not consistent. The reason is more devices you have, more time it will take for getting a mapping address from the pool. The solution is this third method which we are going to learn now, called PAT, Port Address Translation, which is also called as NAT, Dynamic NAT Overload. Why it is called Dynamic NAT Overload? We saw yesterday there are two addresses in the pool. Now, I'm going to say all this computer, I'll remove the static NAT also. So you don't need to worry about this address. Now, we got only two addresses given by ISP. One is assigned on the interface. Actually, that one address is more than sufficient if you're doing PAT. But to be on safer side, we also got another IP address. We have it on the pool. Why it is called as dynamic NAT overloading? Overload means what? In a bike, only 2% should go. In a motorbike or scooter, only 2% should go. But you might have seen 3, sometimes 4 also go in a bike. That is overloading, right? In dynamic NAT overloading, any number of inside computers. There should be some limit. How can you say any? Yeah, 65,000, let's say 65,000 plus actually. 65535 actually. 655 is the maximum port number you have. See, this is going to use port number, right? So we also have some reserved port number. Cancel that reserved port number like 1024. All other port numbers. That is why I say it's somewhere around 65,000 inside device can be NATed to single address. This will also use this address. This will also use this address. This will also use this address. 65,000 approximately. 64,000 to 65,000 devices can get mapped to one single address. That is why it is overloading. Overloading. Overload. Why it is called as port address translation? Because port number involved. Why is the port number needed here? Let's say this alpha was asking for Yahoo. This beta was asking for Facebook. And gamma was asking for YouTube. Now, all these three is going to take one single address. Yahoo will reply to this address. Facebook also replies to the same address. YouTube also replies to the same address. Now, the router is in confusion. To whom should I give Yahoo? To whom should I give Facebook? To which one I should give? YouTube. Why? Because for 10.0.0.1, 10.0.0.2, 10.0.0.3, same address is given. So when Yahoo is replying, sorry, why did I put 2, 3? Same address is given. When Yahoo is replying, it comes to this address. YouTube also comes to this address. Facebook also comes to this address. The replies, same address. Now the router do not know really who asked what. The router will not read your payload, Yahoo, Facebook, YouTube. No, router will read only the addresses. Router is what address? Layer 3 address. Router will not keep track of what these computers are asking. That is not router's job. You are going in a government bus to meet a collector. Why will conductor need to maintain that information? His job is to get money, give ticket, stay. Even if you say I'm going to collector office, he will stop in the collector office stopping, but he will not remember you went to collector office yesterday. That's none of his business. Conductor's job is to collect the money and give ticket, whistle the bus so that bus will move, whistle the bus so that bus will stop. That's all. Router is like conductor only. So to solve this problem, port number is also considered. See, when a PC send a packet, in layer 4 there will be port number. Do you agree? Layer 4 will have port number. Every PC sending packet, it will have 7 layers. In that fourth layer, there will be port number. Let's say the port number is given by alpha is 555. Beta is 999 because it's a random port number. Gamma is giving 444. So now what this router does, it gives this address and it also keeps track of the port number. It copies this port number to the NAT table. Okay, 9999 4444. Now, when Yahoo replies to 10001, the layer 4 port number will be 555. So with this 555 only, it knows that Yahoo I have to give to 10001. YouTube will be replying to 999 of 11001. 999 is packets are for 10002. Facebook will be replying to 4444 destination port number, layer 4 port number, and IP address 11001. So with the help of port number, router identify this packet belong to gamma 10003. Did you understand how the port numbers matters here? Because of this port number only, the reply packet traffics can be forwarded to the right initiators. See, networking, the sender, requester can also be called as initiator. Initiator, responder. Who is responder here? Facebook, YouTube, Yahoo. When you are in some meeting, network technical meetings, you use this type of terminology. They will be happy to know that from you. They will know you as a big engineer. Initiator, responder, instead of saying sender, receiver, that everyone will use. All right. Now, we understood the purpose of considering port number. This NAT overload or PAT makes the router to consider the port number also during the data receiver, sending and receiving. While sending data and receiving data, NAT overload is telling the router, look into the port number in layer 4. By default, the routers don't do that. By default, router will only see the destination IP address, source IP address. Now you have enabled that conductor to keep track of where you're going and where you're coming from. Right. Some parents are like that. They will tell the conductor, என் பையன் எத்தனை மணிக்கு பஸ் வரான், எத்தனை மணிக்கு இங்க பாத்தீங்கன்னா பஸ் ஸ்டாண்ட்ல பாத்தீங்கன்னா சொல்லுங்க எல்லாம் சொல்லுவாங்க. எனக்கு அப்படி ஒரு கதை இருக்கு சின்ன வயசுல. So on top of this normal routing job and NATing job, the router gets additional translation port number to port number. See, 5555, this after translation also same port number. Sometimes there may be two devices coming with the same port number. Because it's a random port number, there are chances, but rare chances, but there are chances. Alpha is also sending the packet with 555. Beta is also sending the packet. Now, it is router's job to translate one. It gives 9999 for the second one. So that the reply from YouTube will come to 9999 port number, and it knows 9999 I have given for 10.002.555.999. It keeps track of to which source address the port number also translated. Here the port number is simply copied, but here the port number is translated. Router keeps track of it. Router is clever enough to do that. If the source port number is same, it will give another port number and it will remember for 10.002 I have given 9999. I did not use the original 5555 because of duplication avoidance, conflict avoidance. Did you understand? Nice question. Sarona is asking a question like this. When you are trying to access a web page, the port number is a reserved port number. True. But which port number? The sender will always have two port numbers. Source port number, destination port number. The destination port number will be 80 because you are using that URL HTTP. But the source port number will be always a random port number, and that will be above 1024 because up to 1024 they are reserved. Here the source port number is what the port patting is translating. IP address is also source translated. Port number is also source only. But Sarna, you understood? In real world, people will use this router. Instead of router, they will use firewall. This is how we draw Cisco ASA firewall. Do your play button mari put your password button mari firewall. Sorry. இப்போ where will the NAT will go? The NAT will go on firewall, the edge device. This is where we have the public connection. The device where you meet the public is the right place for NATing. Understood? Now, configuration. As usual, you should have NAT inside, IP NAT outside on this interface. All right, which we already have. And what I'm going to do is I'm going to remove the static NAT and dynamic NAT which we configured earlier. Show run. We have an access list. Sorry, we have a pool. No. Here is the pool. We have a pool with these two addresses. And to match the source, we have an access list called 10. So the NAT statement is calling the inside source as well as the address to which translation to happen. And this is static NAT. I'm going to remove all of this. I will remove the static NAT. I will remove the NAT statement. I just want to leave this pool. I will use the pool. The next what I will do is I will also I'll write another access list. I'll remove the old access list. No access list 10. So now if you see show access list, no access list, show IP NAT translation, no NAT translation. As a result, the ping will not be successful. Ping will not happen from any of these computers in the LAN. See, this is I'm pinging myself. I should ping this. This it won't ping. So not only this computer, no computers will ping because they don't have an address to get the reply, a routable address to get the reply. Yeah. So now we are going to do NATing. On this two interface, we have NAT inside and outside. I'm going to write an access list saying access list 10 permit any. That's it. Permit any means what? Everyone. Meaning what? Everyone should get natted. Now I will say IP NAT inside source 10 pool source list. List means access list 10 pool. The pool name which we gave in the previous class is add hyphen collection. And very important, you have to put the overload keyword. This is the on command you are doing additionally. Just one command that makes this pat. That's all. Now let us verify. Show access list. Any is there. Permit. And then show IP NAT translation. Nothing will be there because it's dynamic NAT overloading. Only after translation, the logs, the outputs, the mapping outputs will be seen. Right now, no mapping has happened because no traffic has been initiated. Let's go initiate some traffic and verify. Now you see I'm pinging from alpha. I'm getting a reply. I'm also pinging from beta. I'm getting reply. I'm also pinging from gamma. I'm getting reply. Now, what is the difference between dynamic NAT and dynamic NAT overloading? This is the difference. You see, only one address is used for every traffic that you initiated. One address 10.0.0.1 also having 11.0.0.1, 10.0.0.3 also having 11.0.0.1, 10.0.0.1 2 also having 11.0.0.1. Every device I've got same. And here, because the port number is 5, the translated address for, see, 10.0.0.2 and 10.0.0.3 have generated the same source port number. It's a simulator, that's why it is showing this port number. The real device, it will be above 1024. So when the port number is same, it gives another port number. It even translates the port number, I told you. And the reply from 3333 is coming to 1024 and it knows it belongs to 10003. Yeah, 24 packet got matched in the access list. 24 packets got translated, it means. How 24? It is to and fro, going and coming. 4 packet from here, 4 packet from here, 4 packet from here, 12. 12 going, 12 coming, reply, you know? All right. The configuration is same like what we did in the previous dynamic NAT. Additionally, one command you added, overload. Are you comfortable? Do you have any question? This is the table. This is the table. Show IP NAT translation is the table. See, it is expired. Once the session is over, it will be there only for 30 seconds. It will go. This is the table. There is no other table. Any other question? All right. So we have seen two important topics, access list and NATing. Access list is just to say who can come in, who can go out, who got access to whom. That is access list, standard and extended. But NATing is when we have devices in a private network. Private networks are unroutable in the public cloud, in the internet. Yeah, in the internet. So we ask the router to put a routable public address in the place of private address. The source address or source, our address is private, that need to be translated. In NAT, we saw three type, one-to-one NAT, only when you want to allow someone to access from outside to inside, and you also want to go from inside to outside, you will go for static NAT. Static NAT is the only bidirectional. If you don't want Yahoo to ping your personal matter, if you don't want YouTube to ping your personal matter, then you will not go for static NAT. Why will you allow Yahoo and Facebook to see your hard disk? You will never do that. You will never allow that. So we go for dynamic NAT. We don't want anyone from outside to ping your computer without your uh, consent, without you allowing through some VPN. Like you use Zoom to control your screen, or WebEx to control your screen, remote desktop. That is a separate application which will do the two-directional NAT. That is application thing. Should not bring that one here. So let's say you have a web page launched in your home and you want someone from outside to see your web page. Then you need static NAT. If you don't have any web page, you don't allow anyone to access your computer, only you access internet, then you don't need static NAT. We will only do what? Dynamic NAT. Dynamic NAT problem is you need more public address, which is not available. So we go with dynamic NAT overloading. Dynamic NAT overloading is what we saw today, which is also called a SPAT because port number is involved. If no port number, then the reply packet will not be able to send to the right initiator. The source port number will get mapped to the same port number if there is no conflict. If there is conflict, it will be mapped to some other port number. And those mappings are managed in the translation table. That is why it is called as translation table. நான் translate பண்ணும்போது இந்த அட்ரஸை கொடுத்துருக்கிறேன். அப்போ ரிப்ளை அந்த போர்ட் நம்பருக்கு வந்துச்சுன்னா இந்த அட்ரஸ்க்கு நான் கொடுக்கணும். வேற இந்த டேபிள் தேவையே கிடையாது. And this mapping is not permanent, you see. It is only during this conversation. Once the conversation is over between this initiator and target, there is no point of maintaining that in one table. This is not a routing table. This is just for conversation to be successful between initiator and the target, responder and the initiator. Practice this once again. ACL and NATing